Hello, and welcome back to another tutorial on Docker. In the last video I showed one of the ways of how to provision a Docker container. Just as a refresher, that way included using bash inside of a Docker container to provision the container's own environment. This may be the fastest and more convenient way since this follows more of a development workflow, but this approach is not the best for a few reasons I'll cover shortly. Today I'll be showing you how to provision your Docker container with a Dockerfile. You can think of a Dockerfile as a sort of recipe list of all the things you want to have inside your container. Once you have a Dockerfile, you can run a simple Docker command to make your own custom image. This is really a better alternative to the first way of provisioning Docker containers for three main reasons. 1, you can see all the things that are going to be put into your container. 2, transferring your images to someone only requires you to transfer the Docker file instead of a massive tar file. And 3, you can use version control tools more easily to see what has been modified across versions. So let's jump straight into how you can create and use your own Docker file. What you are looking at here is a Docker file that accomplishes exactly what we did in the last video. A Docker file works by first specifying a Dockerfile command, like from, run, or cmd, and then specifying arguments to those Dockerfile commands. I'm only using a few commands here, but I'll put a link in the description for where you can find a reference to all the Dockerfile commands you can use. So let's go line by line in this Dockerfile. The first line here uses the from command. This tells Docker to build all subsequent commands off the latest Ubuntu image. The next few lines are run commands. Run commands are by far the most common Dockerfile command. The run commands tell Docker to run these bash commands inside the container. Each one of the run commands are actually spinning up a new container automatically in order to run the specified command in. Once the run command completes, a new image gets created from that spun up container, and then the container deletes itself. This keeps happening after every run command to build up your image layer by layer. The first run command just updates and upgrades our container. The next run command installs Python 3. The last run command writes the Python code we wrote in the last tutorial into a file called mypyapp.py in the root folder. There's a couple things I'd like to point out with these run commands. Notice in the second run command how I didn't have to install Vim because I don't actually need a text editor here. I'm not using the container as a development environment like we did in the last video, so I don't need things like editors in my container. The second thing I wanted to point out is that the last run command is just writing the Python code straight into a file with bash's echo command. This part here is the Python code, and this part here is where I'm telling the echo command to redirect the Python code to the file called mypyapp.py located in the root folder. I know this is kind of long and ugly to look at. Luckily, there's a better way to get our Python code into the Docker container. But let's put a pin in this for now and we'll come back to that. Continuing on, our last Dockerfile command is the cmd command. The cmd command is used to specify what the default command is when the image gets spun up. Similar to how an Ubuntu base image has a default command of bash, this is our opportunity here to specify some other default command. If there is no cmd command in the Dockerfile, then the default command will be whatever the default command is in your base image, which for us will be bash, since we're using the Ubuntu as a base. For the cmd command here, we are setting up the image to have a default command of python 3 root mypyapp.py, so that our application will be the first thing to run if no command is specified when spinning up a new container. So let's run this in the command line to see what happens. The command to run a Dockerfile is the following, where the -t specifies the name you want to give your image, and the / at the end specifies the location of the Dockerfile with respect to what folder you're currently in. After calling Docker images, you can see that our new image was created. Now let's spin up a new container from that image. And that's all there is to it. One last thing I would like to do is slightly modify the Dockerfile so that we don't have that long, ugly string echoing that Python code to a file. So instead of having this line, let's replace it with the Dockerfile copy command. The copy command tells Docker to copy the mypyapp.py file that's on the host computer into the image that we'll be creating. Now let's create the mypyapp.py. Now let's rebuild the image. One thing I wanted to point out here is that because we have already built the image once before, Docker will use part of the previous image to help build the new image you're creating. Docker is smart enough to know that you have only changed step 4 of the Dockerfile, which was the copy command, and it knows the steps before it were not changed, so it used cached data so that the previous steps wouldn't have to be repeated. However, notice how in step 5 it didn't use cache. This is because whatever step you modify in a Dockerfile, all subsequent steps after that step will have to be rerun. This makes a lot of sense because you are building up an image layer by layer. If a previous layer has been changed, that may have propagating effects for the next layers to come. So Docker makes sure to build all subsequent layers after the modified step. Now let's run the docker run command to make sure everything works. Looks good. If we look at Docker images here, we will notice that there is an image that has none for its name and tag. This image was actually the first image we created with the Dockerfile. There can't be 2 images in Docker with the same name and version tag, and because we renamed the second image as pyappimage:0.1, that removed the name from the first image that we built. We can get rid of this Docker image by doing a docker rmi command using its image ID as its name, like this. If we wanted to keep the previous image for whatever reason, we could simply have incremented the version tag for the new image we built, like this. And now we have 2 images with different versions. Obviously in this case they are the same exact image since I just used the same Dockerfile to create both of these, but this mechanic could come in handy when you want to keep track of features from different Dockerfiles, or if you intend on modifying the contents within a container by using the bash command during development or testing. So that's all I have for this video. You can find the Dockerfile and Python code I wrote in this tutorial on my GitHub page that I've linked in the description. I'll be adding more Dockerfiles and programs to my GitHub as we get further along in these tutorials. There's still a lot of other cool things Docker can do that I'd like to show you, so keep an eye out for more tutorials. Thank you all for watching.